All right, welcome. Today we're essentially becoming detectives, but our crime scene, it's our own minds. We're going to try and crack the code of the mental lexicon, that huge, kind of mysterious but absolutely brilliant web of words that we all carry around in our heads. So let's start with this question. What does it actually mean to know a word? I mean, it sounds simple enough, right? But as you're about to see, this is the central mystery we're diving into. The second you start digging, you realize that knowing a word, whether it's cat or cognitive, is an incredibly complex thing, way more than just having a definition memorized. And this table here, well, it breaks down that mystery perfectly. You see, knowing a word isn't just one skill. It's at least 6 different things. You've got receptive knowledge, that's what you understand when you hear or read a word, and then you've got productive knowledge, what you can actually say or write yourself. And this applies across the word's form, its meaning, and its use. So you might recognize how a word sounds, but not know how to use it, or know what it means, but you can't spell it. It's this fascinating, multi-layered skill. Okay, so how do we even investigate this hidden system? Well, our first big clue actually comes from our own mistakes. You know, those slips of the tongue when you mean to say a pack of lies, but what comes out is a lack of pies? These aren't just random errors. As the linguist Jean Aitchison points out, they're like these little windows into our mind's filing system, giving us a peek at how our words are actually organized and connected. So here's our game plan for this investigation. We'll start with our cognitive toolkit, then we'll uncover the conspiracy of word storage, dig into the mystery of meaning, and then chase down the clues behind high-speed retrieval. And finally, we'll deliver our verdict on the case of the mental word web. All right, first things first. Every good investigation needs a framework, right? A set of tools to analyze the clues. And for us, that framework is going to be cognitive linguistics. Now, the crucial point here, the thing that really sets cognitive linguistics apart, is that it completely rejects the old idea of a separate language box in the brain. Instead, it says that language is built from the ground up. It's fundamentally shaped by our physical experiences in the world, and it's connected to everything else, our memory, our perception. It's what we call a usage-based model, not some abstract rulebook. So this brings us to our first major puzzle, the storage problem. Think about it. How on earth does the human mind file away an average of 50,000 words, often way more, and still manage to retrieve any one of them in milliseconds? It seems almost impossible when you stop to think about it. So are we dealing with a simple alphabetized dictionary in our head? Just a long list? Or is it something far more dynamic, more interconnected? This is really the central question of word storage. And, as the evidence piles up, that simple list model just doesn't work. The mind is organized much more like a living, breathing network. The leading theory here is the semantic network, or as Aitchison calls it, the cobweb theory. The idea is that each word is a node, like a point in a web, and it's connected to tons of other words by links that represent all sorts of relationships, synonyms, opposites, things that just tend to show up together. So when you hear the word doctor, a jolt of activation spreads through the network, warming up related words like nurse, hospital, and sick, which makes them way easier and faster to access. That whole process is called priming. Okay, let's move on to our next mystery, which builds directly on this. So we have a web of connected words, but what is the thing we're storing? What exactly is a word's meaning? Is it like a neat, fixed container of information, or is it something a lot fuzzier? Now, in our investigation, we've got 2 main suspects. The atomic globule theory suggests that meanings are built out of a set of universal building blocks, kind of like Lego bricks. But then there's prototype theory, which argues that meanings are organized around a central, best example of a category. And honestly, it's this second suspect, prototype theory, that has the most evidence on its side, because it just fits so much better with how we humans actually seem to categorize the world around us. Let's put these theories to the test with Aitchison's really memorable phrase. This idea gets right to the heart of prototype theory. Does it even make sense to talk about some birds being better examples of the category bird than other birds? Oh, absolutely it does. For most of us, a robin is a fantastic example of a bird. It flies, it sings, it nests in trees, it checks all the boxes. A penguin, on the other hand, is still a bird, but it's a weird one. It doesn't fly. This shows us that we don't treat all members of a category equally. We're constantly grading them against a mental prototype. And this fuzziness is absolutely crucial. It's what allows for things like metaphor and creativity, stuff that a rigid Lego brick model of meaning really struggles to explain. And you can actually see this whole process playing out in real time when kids learn to talk. Aitchison outlines 3 stages. First, there's labeling. A kid hears the word bongaloo and connects it to the family dog. Then comes packaging. This is where they test the boundaries. Is the neighbor's cat also a bongaloo? They're trying to figure out the prototype. And finally, there's network building, where bongaloo gets correctly sorted into the web, connected to animal and pet, but separate from cat. All right, now for our final and maybe the most impressive puzzle of them all, retrieval. We've talked about storage and meaning, but how do we access all this information at the speed of conversation? It's a mental sprint that's happening constantly. I mean, really think about it. The moment someone starts speaking, your brain is instantly anticipating and sifting through tens of thousands of options to figure out what they're saying. This is speech recognition, and it's an unbelievable high-speed race against time. So how does it work? Is it like the cohort model, which is kind of like a horse race? When you hear the sound ka, a whole cohort of words, cat, candle, canopy, all jump out of the gate. As you hear more sounds, the less likely horses get eliminated. Or is it more like that spreading activation model we talked about, where hearing a word is like a flash of lightning that lights up a whole network of related ideas all at once? The truth? The evidence suggests our brains are clever enough to use both strategies. Okay, now let's flip the coin. We've talked about understanding words, but what about producing them? How do you go from just an idea in your head to picking the single perfect word out of that huge, sprawling web of options to actually say what you mean? And here again, we've got competing models. The stepping stone model suggests it's a linear path, a one-way street. You start with the meaning, find the word, then get the sound. But the interactive activation model suggests it's more like a busy two-way highway. Information flows from meaning to sound, sure, but it also flows from sound back to meaning. This helps explain things like those tip-of-the-tongue moments, where you know the meaning and even what the word sounds like, but you just can't quite grab it. So, after following all the evidence, where does that leave us? What is our final verdict on this incredible system that's working away inside all of our heads? So, what's the big takeaway here? It's this. That whole metaphor of a dictionary in the head is just fundamentally wrong. It's not a static, alphabetically ordered book. It's a living, dynamic, constantly updating network where words exist in this rich context of sound, meaning, use, and association. And this isn't just a theory. Early attempts to model this stuff in AI, like a simple program Aitchison called Dumbbella, prove that you can't build a system like this just by programming in fixed dictionary definitions. The human lexicon is flexible, it's fuzzy, and it's based on lived experience in a way that rigid computer systems really struggle to copy. And that leaves us with a final, massive question. The human mind is not a simple computer. Its lexicon is messy, it's driven by prototypes, it's deeply connected to our bodies and our world. So as we keep building more and more sophisticated AI, the challenge remains. How do we model this beautiful, chaotic, and uniquely human word web? The case of the mental lexicon, it seems, remains very much open. Thanks for joining me on this investigation.